This lesson is on fractional exponents and radicals. If you see an example below that is similar to the current question you're working on, you can download the app referenced in the video caption and use this app to quickly navigate all of my Math 10 lessons and examples. So you can use this app to go directly to the example within this lesson. Of course, pause this screen to take a look through those examples if you want to do that. If not, let the video keep playing and you'll go through the entire lesson. But again, you can always go to use the app and use that to navigate through the examples in the lessons. So for switching between exponential and radical forms, the lesson portion of this is actually pretty straightforward, fairly short, and most of this lesson will comprise examples. To switch between these two forms, we use the below definition. The nth root of a to the b is the same as the nth root of a in brackets all to the b, which is the same as a to the b over n. So the main ones that you usually deal with are going from radical form here to exponential form right here. And don't worry, we'll look at an example below with some numbers to make this a bit more clear. So it's a good idea to memorize this definition even if it's on your formula sheet, as you will likely use it a lot. And it's not too difficult to memorize. I'll show you kind of how I memorize it. An example with numbers below. So we have the cube root of 2 to the 4 is equal to 2 to the 4 divided by 3. So this 4 divided by 3 is all part of the exponent. And so the way I memorize this rule is the index here of the radical, that is what will go to the bottom of the fraction for the exponent. And then the exponent tied to the radicand here, that will go to the top of the exponent fraction. So 2 to the 4, I think of it as like 2 to the 4, this is already in an exponent and it goes to the top of the fractional exponent, and then the index goes to the bottom. So think of it, if you remember just that this 4 always goes to the top, then this number needs to go to the bottom. For most questions, you will be converting from a radical to exponential form. So that's the radical form there, and the exponential form over there. So let's dive into examples. Example 1, evaluate 8 to the 1 divided by 3 without a calculator. So that 1/3 there is all part of the exponent. The exponent is 1/3. Let's rewrite this in radical form, which we are more familiar working with without a calculator. So 8 to the 1 divided by 3. The bottom of our fraction here goes to be the index. The top of the exponential fraction here it stays with the radicand here. And of course 8 to the 1 is just an 8, and the cube root of 8 is of course just a 2. So please do become very familiar switching from exponential form here to a radical form. Example 2, evaluate 25 to the 1/2 without a calculator. Again, 1/2, that is all within the exponent. Let's rewrite this in radical form, which we are more familiar working with when we're not using a calculator. 25 to the 1/2, so the 2 here becomes the index. The 1 becomes the exponent still tied to the radicand here. And 25 to the 1, and of course, is just a 25. And we don't need to really write this 2 here, so I'm not writing it here. So this is just the square root of 25. So you can kind of remember anything to the half will always just become a square root, because the 2 becomes the index, which just means it's a square root, and the 1 doesn't actually change the radicand here. And what is the square root of 25? That is just a 5. Example 3, evaluate negative 125 in brackets all to the 1 divided by 3 without a calculator. Again, 1/3 is the entire exponent there. Let's rewrite in radical form. So we have negative 125 to the 1/3. Where does our 3 go? That becomes our index. And the 1 stays with the radicand here. And anything to the 1, of course, is just itself. And what is the cube root of negative 125? That would be negative 5. Negative 5 times negative 5 is positive 25, and then positive 25 times negative 5 again is negative 125. Example 4. Evaluate 9/16 all in brackets to the 1/2 without a calculator. Again, let's rewrite this in radical form. So don't look at anything over here yet. Follow me as I go through this question. We have 9/16 to the 1/2, what we start out with. To our next step, where does the bottom of our exponential fraction go? It goes to become the index. The 1 here becomes the 1 there. And again, to the 1/2, that's just the same as going to be a square root, because a 2 is just a square root, so we don't need to rewrite that here. And then, of course, a 1, I don't need to rewrite that here. And our multiplication rule for radicals applies for division as well as multiplying. So square root of 9 divided by 16 is also equal to the square root of 9 divided by the square root of 16. And then the square root of 9 is just a 3, the square root of 16 is just a 4. So as I mentioned, the multiplication property of radicals is also true for division. So that was used from going from this step here to this step here. So remember, of course, you can use that going the other way. So kind of think of it as you need to have like similar things here. Both have to be radicals, and then you could put them both underneath an entire radical. Sometimes you'll want to go the other direction when you're simplifying something. So that's the multiplication property written for division. And again, that's just showing the law that we used here. Example 5. Write 5 to the 3/5 in radical form in 2 different ways. Okay, so going from exponential form now to radical form, our 5 becomes our index. The top of our fraction in our exponent becomes the exponent tied to the radicand. So that's one way. And then another way was just if you wanted to bracket this entire thing and just pull this cubed out from underneath. And that is also acceptable. You'll get the same thing if you put either of these into your calculator. And you can choose which one of these you want to use when solving a question. Sometimes one is easier than the other, i.e. or quicker than the other. Let's look at example 6 now. Write the cube root of 2 to the 4th in exponential form. So our index here becomes the bottom of our exponent fraction, and the 4 here becomes the numerator in the fraction for the exponent. And that one's done already. Example 7. Write the 5th root of 15 to the 7 in exponential form. Well, doesn't this look so complicated? Well, it's not, because all they're asking for is you to rewrite it in exponential form. So where does our index go? Where does our 7 go? Our index goes to the bottom of the fraction for the exponent. The 7 goes to the numerator for the fraction of the exponent. And you're finished now. You've written this in exponential form. Example 8, evaluate 0.16 to the 3/2. So we have a decimal here. If the question has decimals, definitely first try to use a calculator. So enter 0.16 within brackets to the, and then within brackets again 3/2. You always want to keep things in brackets when you're using a calculator. Say the numerator of a fraction, the denominator of a fraction, an exponent, like kind of separate parts of questions. Your calculator will not know automatically that it needs to keep all of the 3/2 in the numerator, for instance. If you put in 0.16 to the 3 divided by 2 without brackets, what your calculator would do is 0.16 to the 3, it would take that answer and then divide that answer by 2. So you would get an incorrect answer. On my calculator, that little hat symbol is for exponents. Yours might be a little different. And the answer is 0.064. All of this type here is what I already mentioned, so make sure that you understand that and always use good practice with your calculator to do with brackets. Example 9, evaluate 8 to the 2/3. Again, 2/3 is all within the exponent there. You could use your calculator here, but it's simple enough to do by hand. We're dealing with relatively small numbers, an 8 and a 2 and a 3. If this simplifies to a whole number, then it should be simple to do by hand. So again, follow my cursor here. Don't look through this entire thing. We have 8 and 2/3 here, and then I rewrite that in radical form. Our index comes from the bottom of the fraction here, so the 3 goes there. The 2 stays as the exponent to the radicand, the base number here. And then what I choose to do on this side is I square the 8 underneath there. So 8 squared is 64, then the cube root of 64 is 4. And in this case, actually over here, let's look at this way. I went 8 to the 2/3, and then I simplified it to keep the numerator of the exponent, the 2 here, on the outside of the cube root of 8. And I find this way a little easier because I know much more readily that the cube root of 8 is just a 2. So I simplify that first, and then I square that to get my 4. And you can see that you get the same number, the same answer in both cases. But here, the more complicated thing was the cube root of 8. You know, that's a 2. Over here, you need to figure out what the cube root of 64 is. Now, that's not too bad. 4 times 4 is 16 times 4 is 64. But, I mean, cube root of 8, that's 2. That's much more easy than figuring out the cube root of 64. But neither are too bad. This is just an example of if you want to simplify to cube root of 8 squared or cube root of 8 and then square that whole thing. But this again was also a proof that you'll get the same answer. And example 10 here, evaluate negative 32 within brackets to the 0.4. Again, if the question has decimals, first try to just use a calculator. So unfortunately, my calculator is not smart enough to give the right answer for this question. I get a domain error. There is an answer though. Let's try it by hand. So follow my cursor here. I'm giving you the entire answer at one go, but please follow my cursor. We start out with negative 32 to the 0.4. I change the exponent to a fraction because I know how to simplify a base number with a fractional exponent into a radical. So we have to the 4 over 10. 0.4, of course, is 4/10. And 4 over 10, simplify where we can. That's just a 2 over 5, divided both the numerator and denominator by 2. And then here, we'll use what we've learned in this lesson, changing this into radical form. So our 5, bottom of our denominator and our exponent, becomes our index. And then the 2, the top of the fraction, or the numerator, becomes goes right here. So again, it could go up here, or it could go negative 32 squared. So you can see I've chosen to put it on the outside of the entire radical because it's easier to find the fifth root of negative 32, which is just negative 2, and then square that to get your answer of 4, instead of taking negative 32, squaring that. That's going to be some big number, and then taking the fifth root of that. So what that would have been is 4 to the 5th. So that's some big number. We don't even need to know what that number is. Just choose to simplify it where you keep this exponent here on the outside of the entire radical. So this is one of the more difficult questions that you'll be asked when going between the exponential form of a fraction and radical form, especially since they give you just a decimal to start out with, and on my calculator it wouldn't give me the right answer for whatever reason. But as you can see, we just use that basic law of converting between radicals and a base number with an exponent. Example 11, evaluate 2.6 to the 3.4 to the nearest hundredth place. So when it says to the hundredth place, you can guess that you'll probably just use your calculator here. So that's what we do, and the answer is 25.76. So make sure you can get that with your calculator. And that is the end of this lesson.